So we're asked to consider the function y equals x squared minus 4. For it, we need to state the domain and range and find the roots and y-intercept. And as a last step, it's asking us to sketch the graph identifying those important points. So how I'm actually going to start out this question is by drawing ourselves a preliminary sketch or a preliminary graph of our function, because that should help us in identifying the domain and range. So let's set it up with our x and y axis. And looking at this, what we can see is we have a x squared term, so that's going to be a quadratic equation. So the general form for a quadratic would be like y equals ax squared plus bx plus c. So the number in front of your x squared term, the a, in our case it's equal to 1. So if you have a positive number there, then you're going to end up with a happy face type graph. If you have a negative number for a, it's going to be a sad face, or the upside down version of that. So we have a positive, so that means it's going to be upwards. We don't have a b term, so in our case, yeah, b is equal to 0. This b term kind of controls the shift of the graph, especially left and right. So that means that if we don't have a b, it's going to be centered about the y-axis. So the last thing here is the negative 4. That's going to be our c value, and this corresponds to the y-intercept. So that means it's going to cross the y-axis at negative 4. So putting all of that information together, what we should find is that our sketch looks something like this. So it's the happy face, it's centered about the y-axis since b was equal to 0, and it's crossing down here at negative 4. Alright, so let's use this now to answer part 1, which was the domain and the range. So let's start with domain. This is the x values that our function takes. So we can write this as x is a part of, and have a look at our graph. So we can see that our function is going to extend infinitely into the negative x direction and infinitely into the positive x direction. So that means the domain is going to cover everything from negative infinity up to positive infinity. And we could also state this as being x is a part of real numbers. These are equivalent, you only need to state one to be correct. The other thing I should mention is that we've got, again, these rounded brackets. That's telling us that we're going up to infinity, but we're not actually including infinity. That's just the convention for that one. Alright, so now we'll talk about range. So this relates to the y values. So if we look at this, it looks like the y values are going to extend infinitely into the positive y direction. However, there's kind of a minimum value here, that it's going to reach. So we said this is going to be like the y-intercept, which was negative 4. So let's pop that in, negative 4. So although my graph doesn't really look like it, it's going to actually definitely pass through that negative 4 point. So that means that when we write this, we need to use a square bracket, okay, because you're actually including negative 4 in this range. So we're going from negative 4 all the way to positive infinity. Again, infinity, we're not actually including it. We're going up to the number just before infinity, but not including infinity in it. So that's what that round bracket means. So that there is our range. So that's the answer to part 1. So part 2 now is to find the roots and the y-intercept. So the y-intercept is quite easy. We've already decided it's negative 4 by looking at this equation. But if you wanted to do it more formally, all you need to do is say x is going to be equal to 0 in your equation. So that means we're going to get y equals 0 squared minus 4. And we get negative 4 out that way as well. So that's the answer for the y-intercept. The roots now, that's going to be where it crosses over the x-axis. So we can see we've got 2 points here that we're going to need to identify. So for the roots, it's like the opposite of the y-intercept. Instead of setting x to 0, we set y to be equal to 0. So all we've got to do is say 0 equals x squared minus 4. And then you have a choice of how you solve this. So one way would be to use the quadratic formula. So that's the equation where you say x equals negative b plus or minus square root of b squared minus 4ac over 2a. So that is one option, but for this case, we have a bit of an easier path. Since we don't have a b term, we can pretty much just rearrange the equation as is. So if we swing the 4 to the other side, we get 4 equals x squared. Then we're going to get x is equal to the square root of 4. But remember, for a square root, you can have both the positive and the negative version of it. So when we solve this, what's going to come out is positive or negative. Square root of 4 is 2. So positive and negative 2, we've got, 2 roots. So x equals negative 2, x equals positive 2 is our answer there. If you apply the quadratic formula, you should get the same thing coming out. Alright, so that answers part 2. So our last part was to sketch the graph identifying the y-intercept and the roots. So we've already done the y-intercept, it was at negative 4. The only other thing that it's asking us to mark in is our roots. So these 2 points here. So this one, that's going to be the one that we just said was at negative 2. And this is the one that's at positive 2. So that there is the answer to that third part of the question. So that's all there is for this video.